Okay, so the question that we are doing today is house robber. Now, what does this means? Let's see. What are we given? You're a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. Given an integer array nums representing the amount of money of each house, return maximum amount of money you can rob tonight without alerting the police. So basically, we have indexes which represent houses which are located in such a way that if you rob two adjacent houses, it will lead to an alarm, and you want to avoid that. So what you can do is you can choose alternative houses. You do not have to choose, say you have n sized array, you do not have to choose n by 2. What your goal in this question is to get the maximum output, and not choose two adjacent houses. Let's see. So the first example that we have is 1 2 3 1. 1 2 3 1. So in this one I can choose this, and nothing else. So this will give me 2. I can choose this will give me 3. Or I can simply choose this single house and, okay, my bad. This and this will give me 4, not 2. And yeah, so that is my answer also. In this case, what I can do is the ideal scenario is choosing this and this. Okay. And in the second question, the 27931. Okay. So in this case, you would want to select this. So the greedy approach for this problem will suggest you to choose the biggest one, and this will lead you to 9 to 1, which is 12. But on the flip side, if you choose this 7 3, um, it will give you 10. And if you pick 1, okay, let's see the answer for this is 12 only. Okay, so this is the ideal case: 9 2 and 1. Okay, but like greedy approach, in the greedy approach you will start from here, you will ignore the first one, you will choose the second one because this is like a great number, but this is not the ideal solution. You will have to first pick 9. Yeah, so this is what you have to do. You basically have to generate the maximum output using non-adjacent houses. So the problem is, so there are like two aspects. So um, for every such problem, what we can do is we can solve the problem on the smaller side. We can see what we are getting for, suppose we have this example which is 1231. In this case, let's see what is the ideal way to choose from these two indexes. So if I am at 1, if I am only given this part, ideal would be 1. Okay, there are like one efficient ways to choose to rob the houses. If I am given 2, so as you can see, the 2 is the bigger one. So basically the maximum of 0th and first indexes will be my answer, the ideal way to go about it. Okay, so 1 2 3 1. Now at the last two indexes, how do you solve the problem? Like, what are the bigger problems and what will be the base cases which will help me solve this. Basically, for one and two houses, we have solved the problem. What we need to do is simply get the zeroth index for one single house, and if we have two houses, just get the maximum of those two. So for the last index, what will be the two cases? So this is like a pick and non-pick problem. um, Either you can choose the last index or you can ignore this index, right? So in the first case where you are choosing this index, what you can do is what you have to do is ignore 3. Okay, you cannot choose 3 if you're choosing this one. So your answer will be whatever you have looted up until this point plus this point, this index. Okay, since we are given the constraint that none of these are negative, so we can safely assume that adding a value will increase the amount only. So if you are choosing this index, you will have to ignore this n minus 1. Sorry, if you're choosing n minus 1, you will have to ignore n minus 2, and you will have to, your answer will be whatever loot you have had up until n minus 1 plus the loot on n minus 1. Oh, sorry, n minus 3 rather. You will have to ignore n minus 2. And so these two, the addition of these two will give you the maximum loot possible. This is the bigger problem that you are trying to solve. So if you choose to not pick this, you can simply return maximum, the whatever loot you have had, maximum and efficient loot up until n minus 2. Okay, this is like the bigger problem that you are trying to solve. So if I have to like formulate this into an equation, so basically um, maximum loot at point n minus 1 will be equal to max of loot at n minus 3, since you cannot choose n minus 2, plus the loot at n minus 1. Okay, and the second will be the case where you ignore this index. So in that case, the loot will be loot at n minus 2. Okay, so this is the bigger problem that you're trying to solve. Now, how do you solve this? You can make calls, make recursion calls up until the point where you have reached the 0 and 1, where you know the answer. For 0, the answer will be, as I stated before, and that index only. And for 0 and 1, the answer will be maximum of these two. So in this way, we can simply solve this question. So let me try to do a try run over here. For, let's say, 27931, for this case, we start from here. So there is one case where we are choosing this. So this is like 0, 1, 2, 3, 4. So for 4, what we need is max of um, 2 plus 1. These are like indexes. For the fourth index loot, what we need is maximum of 2 plus the loot at 2 and the loot at uh, 4, the loot at 4 and the loot at 3. Okay, for loot at 3, what we need is maximum of loot at 1 plus loot at 3 and the loot at 2. Okay, and for the loot at 2, what we require is loot at 0 plus the loot at 2 and the maximum of loot at 1. Okay, for 4, we require this will not be okay. Yeah, this would be yeah, the for the fourth one, the loot will be 1 only. Okay, so this will, we can safely say this is 1. For 0, the answer will be 2, and for 2, the answer, for 1, the answer will be 7. Okay, so maximum of 7 and 2 plus For 2, the answer will be 9. So 11 and 7. So this will give me 11. So this will give me 11. So for 2, I will get 11 plus 1 from 4. So 12. So maximum of 12. And from 1, we will get maximum of 2 and 7 is 7, plus so we have already I think we did now on this one. No, we did not. Okay, for 3, the value, the answer, okay, so for 3 the value is 3 only. So 7 plus 3, 10. And for 2, we found out that the value up until this point, okay, up until this point the value was I think 11, right? So this will give me 11. So 11, so maximum of 10 and 11 will be 11. So this will give me 11, this will give me 12. The answer will be 12 in this case. Okay, so this is how we will be solving this problem. Let's do the dry run on the second one. 1 2 3 1. 1 2 3 1. So for, if I want to like get the answer for 0 1 2 3 third index, the answer will be 1 plus 3. Let's move it over here. 1 plus 3 maximum, or 1 plus 3 or 2. And for 1, the answer is simply maximum of 1 and 2 is 2, plus for 3 the answer will be either uh, for 3 the answer will be either 1 plus 3 or 2. So let's see what is the value of 2. For 2, the answer will be okay, no. So for in this case, the 3 will have not up until 3, but this means the value at 3. So for the value is 3 is 1. So for 1 it was 2. So 2 plus 1 will be 3. And for 2, the answer will be up until, this is up until 2. So for this, the answer will be 1 plus 2, which is nothing but 1 plus 3 4. Okay, my bad. 1 plus 3 4. And the second one will be simply 2. Okay, so not 2 but rather 1. So the value at 1 is 2. So from 4 and 2 we will get to 2. Oh, sorry, 4. Maximum of 4 and 2 is 4. And amongst these 2 3 and 4, I think this one was 3, right? If I'm not wrong, one was this and one was 2. This was giving 2, so this was 3. So the maximum of 3 and 4 will be 4. So the maximum value that we can load will be 4 in this case. Let's try to code this ASAP. So if the num start size is, let's say 1, so if there is like single index, so we will just return that index. For other cases, we will keeping a track of this overlapping subproblems using a DP array, which will simply be, this will be initialized to 0, and so for the first and second index, for the first index we will like, give the index value itself, and for the first index we will take the maximum of 0 and 1. So dp of 0 is simply nums of 0, and for dp of 1 we simply can do a max of nums of 0 and nums of 1. Okay, so now for other indexes, we can use recursion to do all the work. So from index I is equal to 2, because we did for 0 and 1. So from index 2 up until num start size, the I pointer goes on. So the formula that we formulated was simply this: for the maximum loot at any index, the answer will be max of either the maximum loot up until point 1 previous to it, which basically means you are not choosing that index for loot. So it will be I minus 1, or a sum of the maximum loot up until I minus 2 and the loot at that point. So this part is something that you have to be careful about. So you are not adding the loot up until this point. You are in fact figuring out this loot. So you are taking the loot of that particular house. So nums of I in this case. And after you are done, what you can simply do is return the value at the last index of the DP array, because that will contain the maximum loot possible for that array. Okay. So I, sorry, not I, nums of nums dot size -1. Okay. So you have the edge cases. You have the base cases, and I think they should pretty much run perfectly. Okay, there is a error. What is that error? So there is a mistake. There's a typo. Let's go. So let's try to submit this. The space complexity for this one will be of n, because we are using a vector, and the time complexity will be, I think we are visiting each array index. This is let me just check once. Okay. Mhm. Mhm. Okay, so I asked ChatGPT for the time complexity. So what he said basically was, while initializing, we are going through that vector and initializing all the values to 0, which is not required, to be honest. So this can be saved, this can be improved, this can be optimized, but this takes O of n. This operation takes O of n time complexity, and then we are initializing the base cases 0 and 1. So this will take like O of one constant time complexity, and then inside the loop we are going from 2 to n minus 1, which basically means n minus O of n minus 2 complexity, which is roughly O of n only. And the last operation basically returns the last index, which will take again a constant time complexity operation. So overall this solution, this dynamic programming solution, will give a complexity of O of n. Yep. So that's all for this video, and space complexity was O of n.